This conference will now be recorded.
Should we move forward? Yeah, we will continue with the pointers. I believe there is no doubt. So with that, we are moving forward on the topic of pointers. So there are two things where we can call the functions, that is call by value, and one another thing is call by reference. In the first call by value, we just share the value as we have discussed while during functions discussion. While coming to pointers, we call by reference. That is across the when we call a function, here we will be sharing the reference, that is the address of the variable itself. That is called by reference. So we will take an example for that. As usual, for the previous program itself, we will consider and move forward. Just a minute. You can see the scan function also is an example of call by reference. Here we are sharing the references of two variables. So we have to declare that we are using an integer pointer. So we are declaring it here. We'll compile the program and see. An exceptions which are not handled, while the exception discussions will be done in the only in the advanced required for advanced programmers. So the input data which is collected in the main function is share the address of that variable is shared here. You can see here address of that variable is shared here, and it is collected as pointer variable. So when we are using this is just an address now. So to access the value we have to use star, that is the value at the address. This is an address of value operator, sorry, value at address operator. Okay, so value at address of input p. So now what we can do is, now what we are doing here is we are returning again a factorial, so we can eliminate this uh, this thing also here. That is, we have one more variable, address of fact also we are sharing. So we are having one more pointer. So we can remove this. So value at the address of factorial will change. So the declaration also, Since the thing is, wherever we are making changes, accordingly, we should make sure that necessary changes are being made. And so this is where we need to have a data of what are the variable declarations, which functions these are all utilized, and how many, which are the where are the locations it is utilized. That is within a function where all it is placed, or how many times this variable is utilized. So now program is done. This is for only to increase the readability, that we are accessing the value at the address of fact underscore p. This one, it increases the readability, since multiply symbol and value at address operator will are same. Okay, so uh, this is this is how it is useful. Here now, if you want, we can return two functions also. If you have one more compilation here over some other variable, then multiple variables are changed. So accordingly, in the calling function, that is main function, uh, these variables are accessible. Wherever the compilation is done, those things are available in the main function also. So this is how we will be using the functions. So do you have any doubts?
No, sir.
Yeah, we'll move forward.
Sir, why we have to keep star in front of declaration?
Can you be louder?
A11.
Hello, can you be louder?
Why we have to keep multiplication symbol in front of the A or B compute variables?
In front
In
of
definition, we have in definition int fact one brackets int star input underscore p. Why we have to keep like that star?
in declaration, you mean to say?
Yeah, yeah.
Here, here in this portion.
Yes, sir. Yes, sir. Second
Okay,
line. Yeah,
this one, no. I'm
yeah.
highlighting here. Okay,
Yes,
this
sir.
is a
Yes, sir.
declaration.
That's
This is a declaration. That is a function declaration. Are you aware of function declaration?
yes, sir. Function call itself.
Yes, function call. There also we do function declaration, isn't it?
Yes, sir.
In globally, that is global means out of main is global. Okay, out of
Okay.
main is global. And so before main is getting executed, above main itself, we will be going for a declaration. That is function
Okay.
declaration. That is, we are telling that I am having my own function also employed in this program. Main is a compiler called function, isn't it?
Okay.
But
Means
I'm
we are going.
we are building our
Okay.
own function. Okay,
Okay.
there also, if you see, we are declaring int, isn't it?
Yeah.
That is variable declarations we are doing it. That is how many variables are shared across the functions. When we have a function call also will be there. That is printf is
Yes,
a
sir.
function, and so function here we are calling the function printf function. Okay, while this printf
Yeah.
function is declared inside the standard library .h.
Fine.
Okay,
Oh.
okay, and so here we are declaring our own function which we are trying to utilize, and so this function definition will be done by us. Okay, function definition in the sense how this function should be working, how this module is programmed to function. Okay, that is definition. And so function definition only we are doing the factorial compilation, this program. This is the definition. Okay,
Okay.
and so what is happening is The compiler, we are telling what are the variables which are shared across the function, so that it can be utilized. Otherwise, what is the data I'm sharing with the function. Okay. And so how many variables which are shared to be declared in the function declaration itself, that is what we have
Okay.
seen in the function. Okay, now we are
Means
sharing a
before main,
before main. Yes,
okay,
that is global. Yeah. Okay. And
before
so
main only this program is going to run.
before main only we will be declaring it. Here
Okay.
if you see, you are declaring the variables. Similarly, function
In
declaration also to be done. That should be
in
done
which
outside.
function we are going to display A value and B value?
No, no. Uh, this is function which are using this A and B is we are using within the
Declaration.
main only. Yes,
Okay,
that is we are doing using in the case one of switch statement. Okay,
okay, sir.
while coming. Okay, and
Okay, sir.
okay, and so coming to function declaration, we are declaring the variables usually. Now we are declaring the pointer variables.
Okay. Means that input A is pointing to the first fourth line.
First pointer variable. This is pointer variable. This is, you know about the star in function and this pointer, no?
Pointer.
What is it?
Yes, sir. The
Yes,
address is
yes,
pointing to
yes,
the variable.
pointer.
Some
Yes,
constant variable.
and so we have to do it like this only. That
Hmm.
usually what is the variable here?
This input underscore P is pointing to the first third fourth line.
Yeah, no, not fourth line. Don't take it as a line. You speak it like variable. Okay, we can.
Okay. Okay.
Okay, so that it will
Okay,
be
sir.
easy for you also to take. So into input underscore p, fact underscore p. I think this also I discussed in the function class. It has to be.
Yeah, now it's clear that
We can do like this also. While it is not compulsory to tell the variable here, that is also fine. Okay,
okay.
this is also fine. This
So
also I have
in this function,
now you usually I
there
prefer
is
lighting like this.
no chance to write.
Huh?
Okay, okay,
Pardon? Usually I prefer
okay, sir.
writing like this.
Yes, sir. Yes, sir.
Okay, since we
Okay, sir.
can clearly see it as a integer pointer. Okay, and so
Okay,
always always segregate yourself that integer pointers are declared separately and normal variables are declared separately. Pointer variables should be
okay,
declared separately. So we can write like this also. While declaration, this is allowed. Even for variables also it is allowed. Even when it is not pointer is not there, this is also accepted.
okay. Sir, in this in this variable, there is no chance to write some written value or like that.
What is the hidden value?
Written value. From that, we are calling you, sir. From that factorial,
Yes.
there is
Yeah.
no chance to print here.
What do you want to print here? Return value. Return value is not required. The
Yes.
thing is, we are changing the value of the variable itself indirectly, isn't it? Here,
So
what
then
is that?
what's the use of that variable, sir?
Which one?
Empty variable, okay. Fourth,
Which one?
fourth variable.
What is
Fourth
that?
variable, start.
Which you want to say?
Fourth variable
Fourth variable means fact.
means that, yeah, yeah, fact one.
No, no. Fact we are using no here. The value of the fact is only changed here. We are assigning what we are assigning. You see, fact we are declaring it here. Fact we are declaring it here, but we are not defining
yeah,
it. Okay,
yeah,
okay, we are not defining it, and so
okay,
what is happening is this address of fact we are sharing.
okay, okay,
That is what we are sharing across fact underscore p. The p, whatever I have kept it as fact pointer.
okay,
Okay,
okay. Means this
and so
fact pointer is going to print this
this
fact
fact
pointer.
pointer takes the address of the fact variable. Okay,
Okay,
fact pointer takes the address of the fact variable, and
yeah,
over the when we are when this is the address of the fact variable, naturally this star symbol over that address means value at that address.
yeah. Okay, sir, it's
Value
clear.
at address, suppose it is 20,000, 30,000. If you say value at the
Yeah,
30,000 address is nothing but fact variable value.
yeah, oh,
Okay, if you see
okay.
here, we have not initialized the fact value. We have
Input
declared
value.
only in the
Yeah,
main. We haven't initialized it. Initialized means define the variable. Okay, here we are defining
yeah.
it. You see,
Fact equals to one, not like that.
address at the fact underscore
Ah,
pointer, value at this address
address of
we are initializing
address
as 1.
one.
Understood? Got
Yes,
it?
sir.
Okay,
Yes, sir, I got it.
okay. And so we'll go for one more program to make this pointer little more complicated. Okay, so we will go for a recursion, that is recursive use, that is we will go for a repeated use of this function call. I'll make a change. I'll make it new program. We go for a recursion. We'll go for a new program itself for void. How to use a function within a function itself. When we do recursions, that is, when we call functions repeatedly, then we should have some format, that is how to come out of that function. That is, when a loop call is there, we should have the facility to come out.
or is it input underscore fact A or N or what's up?
Pardon?
Is it
I'm not getting
input underscore fact A or N or F?
this one, no? This one.
Yeah, sir. Initialize you are given yeah, no. In scanf you are given A.
Oh, 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 okay, okay.
In this in recursion function you are given F.
This is to tell that it is function. I'm using this input at function.
Okay.
Okay. I'm differentiating it. Here also
Okay, sir.
fact I'm using now. This is a f function. F
Yeah.
fact variable. This is
Okay.
factorial
Yeah.
function. Okay. You can keep it
Okay.
according to your readability. It
Okay, sir.
should be
Means
readable to you.
you are
Whatever
writing
within
now
the function I'm writing as f. Okay. Whatever is
fact
within the
underscore
function,
F into
f.
I.
Yes.
Fact underscore F into I.
Now we should write it. Huh?
Ah, yes.
Okay. But it's regression,
Written
no?
fact underscore F. Sir,
Huh? So it's a recursion, no? And so we will be calling the variable once again, repeatedly.
means fact underscore recursion.
Yes. Now we need to call the function repeatedly. That is, we will be calling the same function in a recursive mode. If you can predict, you can predict, no doubt. See, now we are calling one more time the function here itself. What function? The same function we are calling. Okay. Understanding now? Always, that is practice one. If we are getting input underscore as 5, here it is suppose p we will take input underscore f. So what is the factorial? P 1 in 1 into 2 into 3. 1 1 into 2 into 3. So three times the loop has to be called. That is first time the loop anyhow will be executed, and so at that time it is initialized to 1. Since I is not equal to input f, else will be executed, and I is 1, and factorial, oh, and the year again factorial will be called. So this time I is equal to 2. So still I input underscore f is not equal, I is not equal to 3, so else will be executed. Already I is 1, and so now it will be multiplied by 2. Okay, since I is now 2, and so into again factor will be called as I is equal to 3. So now we have to make it as greater. Okay. Now 3 will be I is equal to 3, but it is not, but it is equal to 3 only, and so again this factorial will be indicated. Now I in 3 into 2 will be multiplied, and so we will get the data. So instead of doing like this, it is always good to do the program in always minus minus. Okay, always it is good to decrease the value, counter value, and make it as 1 or 0. That combination will be always good. So now we will be changing it here. Since that gives always a clarity, instead of doing for plus plus and increasing the counter, always it's a good technique to go for minus minus. So this time we are doing it as factorial of 3 as 3 into 2 into 1. So so sorry. So input input is 3 here value. So 3 is not equal to 1, and so else statement will be executed. So 3 into, again factorial will be called, this function will be called again. So 3 into factorial will be called, and so here this time now 3 minus 1. So 3 minus 1 is 2. So 3 is here, and into again 2 will be called, and so else statement is again executed, and so 3 into 2 is also existing, and factorial will be called input minus 1. So 2 minus 1, and so input of 1 will be the value, and since input of underscore minus f is equal to 1, so return will be 1. And so right that time we have the factorial value 3 into 2. So when it reaches this statement, 3 into 2 will be returned. Okay. Sorry, I'm repeating once again here. I made a mistake while explaining you. That is, when factorial will be called here, after factorial execution, when this input is 1 only, we'll be returning 1. Okay, otherwise when it is true, else statement will be executed. So repeatedly function will be executed, and once this function is executed, in the calling functions, repeatedly returns will be executed, returning. And once repeatedly return statement is executed, finally it will be landing at this return. Okay, the loop will be, that is, we have to what we have to do is this, we have to split into 3-4 programs. That is, similarly, this function call will be called as one more module of these functions. That is, within this fact underscore f input underscore f of -1, again one more function call will be there. Okay, within that function, this return functions will be returning the value here. And so while running the first, when running the first with value 3, you see it here 3, this function will be returning, a function call will be called here, and it will be returning a value of fact underscore f, and again a one more function will be called, and that will be returning one value. That is, in that call it will be returning 1. Okay, that return, once that is returned, then function will be broken, function will be existing, and so finally we'll be landing at this return. Okay, so once we are getting this calculated, and this fact underscore f will be returning the main program here. If possible, I'll make a slide in the next class. Okay, I request you to execute this program and see. Okay, that function has gone. I request you to do that program. We'll see why the program is not executing in the next class. And next class we'll be seeing about the discussing about the data types, and then we'll be going for arrays, and then next topic will be strings. I think we should be able to close the uh, course by that. And so if it's better that you do some compilations, and if you have any doubts you can ask. While for this program, I doubt that if unless a presentation is there you can't understand. I'll try to make a presentation on that since there is a regression. Okay, is that okay for you? Okay then, any doubts till time? Thank you, bye.